Have you ever wondered why we can't hear the colossal explosions of distant stars or the hum of a passing spaceship? The answer lies in the very nature of sound itself. You see, sound is not like light that can travel freely through the vacuum of space. Instead, sound is a wave of pressure changes in the air or any other medium it's traveling through. Imagine a pebble thrown into a still pond. The ripples spreading out are like the sound waves expanding from its source. But in the vacuum of space, there is no air, no water, no medium for these waves to ripple through. The result? Silence. Complete and utter silence. This is why, despite the fiery ballet of starbursts and cosmic collisions, the universe is essentially a silent movie. So the next time you watch a sci-fi movie with loud space battles, remember, in reality, space is a silent symphony. Black holes, the mysterious monsters of the cosmos, but do they really appear as dark voids swallowing everything around them? The common depiction of black holes as ominous, light-devouring vacuums of space has captured our collective imagination. But is this image accurate? Well, not quite. Let's start with what we know. Black holes are regions in space where gravity is so strong that nothing can escape, not even light. That's why they're called black holes. But here's where things get interesting. These celestial phenomena aren't merely invisible voids. In fact, they have a rather dramatic way of making their presence known. Enter gravitational lensing. This is a fascinating effect predicted by Einstein's theory of general relativity. When light from distant stars passes near a black hole, the colossal gravity of the black hole bends the light's path. This bending of light creates a unique and captivating visual phenomenon. It warps the space around the black hole, creating what can be described as a cosmic mirage. Think of a black hole as a colossal cosmic lens. As light from stars and galaxies passes near it, the light's path gets bent, creating a circular arc of light around the black hole. This arc, often referred to as an Einstein ring, acts as a natural telescope, magnifying and distorting the images of the universe behind it. So rather than being invisible, black holes can be detected by the way they change our view of the space around them. In essence, this gravitational lensing paints a portrait of black holes that's far more intricate and fascinating than a simple black void. It's a spectacle of light and gravity that's as mesmerizing as it is enigmatic. So, the next time you picture a black hole, don't imagine a dark, empty void. Instead, envision a cosmic lens, distorting and bending the light of the universe around it. So rather than dark voids, black holes are more like cosmic lenses, bending and distorting the light of the stars and galaxies behind them. Ever seen astronauts floating around in their spacecraft and thought they're in zero gravity? Well, it's time to put that misconception to rest. You see, gravity is a force that exists everywhere in the universe. It's what keeps our feet firmly planted on the ground, and the Earth in its orbit around the Sun. Now, you might be wondering, if gravity is everywhere, why do astronauts float around in space as if there's no gravity? The answer lies in understanding the concept of free fall. Imagine you're in an elevator and the cable snaps. You and everything inside the elevator would start falling towards the ground at the same rate. For a brief moment, you would feel weightless, as if you're floating, even though gravity is still at work. This is exactly what's happening with astronauts aboard the International Space Station, or ISS. The ISS is essentially in a constant state of free fall towards the Earth. But because the Earth is curved, the ISS keeps missing it and continues to fall in a circular path around the Earth. This is what we call an orbit. So the astronauts are falling along with the ISS, creating the illusion of weightlessness, or what we often mislabel as zero gravity. But in reality, the gravity at the altitude of the ISS is still about 90% of what we experience on the surface of the Earth. It's just that everything inside the ISS is falling at the same rate, creating this feeling of weightlessness. This illusion of zero gravity has fascinated us for decades, and it's one of the reasons why space exploration seems so exciting and otherworldly. But it's important to remember that even in the seemingly weightless environment of space, gravity is still present. It's just experienced in a different way. So while it might look like zero gravity aboard the International Space Station, it's really just a never-ending fall back to Earth,